My wife and I bought a bunch of these novelty Halloween pumpkins at the end of the last Halloween season, and they have kind of a cool LED effect in them. There's a reflector built in that turns and makes it look a little bit like there is a candle glowing in the back. And I wanted to know if I could do more with this than just turn it on and off with batteries. If we take the pumpkin out of the box, we see the Try Me button, which we can click on and off. And if we take that out, we see that it's actually, interestingly, a pair of 0.1 inch spaced pins that just lead into the compartment of the pumpkin. You take that out and plug it back in, and the box attached to the button just contains 3 little coin cell batteries, giving you about 4.5 volts. So plug that in, you can turn it on and off. When I saw this last year, I thought, well, certainly, we can control this remotely, and we could just run some lines back to a control box. So if we take the pumpkin apart, we see inside of it there is a motor and some of these shiny foil pieces of plastic which create the reflection effect. And then in the front there are a few LEDs that provide the lighting. There's also some circuitry involved there that connects the on-off switch as well as the 2 pins that we saw. So initially I thought, we can plug something into those pins and remotely control these pumpkins using some sort of computer. I found though, as I tried to do that, that I really wasn't prepared and I really didn't have the background on what I was trying to accomplish. I looked at it first from a programming perspective of a microcontroller where I was feeding in timestamps to match it to songs, and it just turned out to be really complex. That Christmas, however, I learned about sequencing Christmas lights and um, light system design using a program called X-Lights, and it inspired me. So I decided to see if I could pursue it this year with Halloween. And so I started to build these pumpkins. I took out all the inside of the pumpkins and replaced it with some WS2811 lights that would allow me to do some sequencing. Um, Initially, tearing out all of the insides of these pumpkins didn't make a lot of sense because what we really wanted to do was to maintain that effect, but it turns out that was going to be really difficult to weatherproof. As we tried to put these pumpkins out last year, we had to take them out, turn them on, bring them back in, and try and guess whether or not the weather was going to be bad. So by using these WS2811s, I was able to figure out how to weatherproof the pumpkins and still accomplish what I wanted to. So see here, I just laid out the WS2811s onto the base, and I'm clipping wires that I'm going to use to solder 2 sides to the strip, the input and the output, and then that strip is going to connect to these 3-pin cables that I got from BFT Lighting. So you can find them on Amazon, and they sell a lot of lighting equipment. They're based in China, of course, as a lot of these companies are. But really, the goal here was to take these connectors and kind of connect all of these things together, and then we could run a single signal and a single wire, I should say, 3-conductor wire out to the pumpkins from a control system and manage manage a show. So what the goal here is to have these pumpkins sing songs and light up according to the lyrics. In this particular situation, I tried to solder some wires and it just wasn't taking very well. So I decided to swap out for a different trio of wires, which worked out a little bit better. I'm going to do it testing here to make sure that I don't have any short circuits. So I do these wiring on both sides. And what we're going to do is after we're done wiring these in, we're going to hot glue the ends that we've just soldered so that they're weatherproof and no water can get in and create a short circuit. Here I'm just adding a little more solder just so we have a really good connection. So what we're going to do before we add the hot glue is I'm drilling holes into the top of the battery compartment. The battery compartment has a door on the bottom, of course, and normally these pumpkins take 2C batteries, but I've drilled holes in these and clipped these pigtails so that we can glue them into place, and that will essentially all the wiring will be weatherproof because of the hot glue. So what I'm going to do is I'm going to glue down the sides of the LED strip to the battery box, and then I'll just sort of stabilize them and make sure that there's no tension on the wires as I'm trying to do the rest of the process. You may have noticed that I overcut the LED strips on either side, and I've found that preferentially, if I have the flexibility to do so, I like to lose an LED and have the full pads available rather than trying to solder to the half pad. And that's just sort of a personal preference. So I'll solder, I'll hot glue the wires to the sides of the battery box, and then I'll put the hot glue over the top of the conductors just to make sure that no water can get in, and I might even end up going over the silicone overlay that's on top of the LED sometimes, but usually it's not required too much. So I've taken my the holes that I've drilled in the top and reamed out a little bit, and I have pushed the pigtails through the top, and I twisted the top of the pigtails just so they were a little bit easier to get through there, but I will untwist them and take off the extra insulation before we're all done. It can be useful, by the way, if you have something to sort of prop your pigtails up on underneath. I've got the whole base mounted in a vise right now, which is super convenient. But anything you can set your base on and then set your pigtails on under, so they're sort of held level at whatever point you want them to be. After you've stripped your wires, you want to make sure that you twist them together so that you don't have like little flyaways happening. You see, I made a mistake here. I twisted all my wires together, and then I realized that I needed the heat shrink on the wires. And the reason this is important is what I'm going to do is I'm going to solder the wires together. Then I'm going to coat the wires in hot glue, and then I'm going to move the heat shrink over the hot glue. And when you heat up the heat shrink, on top of the hot glue, the heat shrink will shrink, and then the hot glue will also melt, and it will come oozing out the sides, and that will create a really solid weatherproof connection. You can be sure that water's not going to get in there. So I've done the one side. If you have an opportunity, what you can do is look up the NASA specification for splicing and soldering. And they have a really solid technique for splicing together two wires. Basically, you cross the wires, you turn one over the other, and then you end up turning them over one another. I don't do a perfect job of it here, but it makes it, it's much easier than the way that I initially tried to splice wires together, which was just sort of trying to line them up in a pair of helping hands or something like that, and hoping that they would stay there long enough for the solder to cool down and weld them together. So I've hot glued the wires. One thing I found, if you put a little too much hot glue, just take some wire cutters or scissors or something, cut off the excess. So what we're going to see in just a moment here, I am going to put the rest of the heat shrink on. And then I have specifically a tool that I inherited that is for heat shrink, but this is a normal heat gun. If you have a heat gun in your garage, that'll do it. This one has a bit of a narrow nozzle, but that's about it. And it's not super visible in the video, but you can see as the heat does go over a few ends of the heat shrink beginning to sort of drool or drip out um, some of the hot glue. Lastly, before you put everything back together, you probably want to test it. Quite frankly, you probably want to test it before you hot glue everything, but I don't like doing that for some reason. Anyway, that's how I made my pumpkin. I hope you enjoyed it.